Hello everyone. So today I'm back with another problem named number of closed islands. Okay. So let's see what it says. Given a 2D grid consists of zeros, that is land, and ones, water, an island is a maximal 4 directionally connected group of zeros, and a closed island is an island totally all left, top, bottom, and right surrounded by ones. Return the number of closed islands. Okay. Let's understand what this problem means. So what is an island? If it's a zero, it's an island. If it's one, it's a piece of water. Okay, area of water. Okay, so this is a piece of land, this is a piece of land, this is a piece of land. All of these constitutes to an island. Okay, similarly this is also an island, this is also an island, and this is also an island. Okay, now what is a closed island? A closed island is an island for which in all 4 directions we have water. Okay, it's enclosed by water. If we see this piece of island, okay, it's all surrounded by water, isn't it? Right, top, left, down, and right. So this is a closed island. We have a piece of water, I mean area of water in the middle also, but ultimately this area is closed, isn't it? So this is a closed island. Similarly this one, it's a closed island. In all 4 directions it's enclosed by water. So this is also a closed island. So this is a closed island, one closed island. This is a closed island, that is another one. So how many in total? We have two closed islands. Okay, so we just saw which are the closed islands. Okay, now let's say, what about this island? Can it be a closed island? No, never, because there is nothing to the top and nothing at the right, isn't it? Similarly for this one, nothing at the right and nothing at the bottom. Okay, so one thing here is sure, that if we have an island on the boundary, okay, or say perimeter, that is the extreme rows and columns, the first row, uh, the last row, the first column, and the last column. If there is an island, it's never going to be a part of a closed island. Okay, so there is no point in checking if island exists in this perimeter or not, right? We can directly skip and we can start looking in this area, isn't it? So this was an observation. Okay, now how are we going to solve this? How are we going to approach this? We are definitely going to start from here. Okay, let me say it in some other way. Let's say we are on a helicopter, okay, in which there are a lot of people. We have the task to determine the number of closed islands. Okay, so as usual, our helicopter is going to traverse this whole area, isn't it? It's going to traverse this whole area. As soon as our helicopter down below sees that there is an island, okay, our helicopter is going to drop all the people down to the island. Okay, we are all of us are going to be deployed at this position. Okay, now from here, all the people are going to spread out in all 4 directions. Some will go here, some will go here, some will go here, and some will go here. Okay, now from here, more people will go in all directions, here, here, then here. Okay, so then people here will go in these directions. We are all of us are spreading out. Okay, like this, like this, like this. At some point of time, few people will reach at this place, at this place, at this place, this place, this, right? All A lot of people are going to reach on the water, right, at some point of time. So when all of them reach water, okay, let's say one guy is standing here. Okay, when this guy finds water, it's going to let its previous guy know that yes, I have found water. It will tell its previous guy that yes, I have found water. Okay, similarly this guy will tell I have found water, this guy will tell I have found water, this guy will tell I have found water. Okay, like this, all of them will let their previous guy know that I have found water. Okay, so when these guys let their previous guy know that the next guy to me has found water, it will let its previous guy know, right? It will let their previous guys know, isn't it? So like that, all the previous people would be informed that water has been found. Okay, water has been found, and at the end, all of us are going to tell that water has been found. And this guy, okay, the main guy, from the position from all the where all the guys were spread out, okay, this guy will be informed that at all four directions water has been found. Had it been the case that in one of the directions water was not found, okay, so it will never be an island. All the people have to inform that at all 4 directions, all the people have informed that they have found water. Okay, they have found a boundary. Okay, then only it will say that yes, it is a closed island. Okay, all the guys at the boundary have to tell that yes, it's a water, it's closed. Okay, so is it something that we know already? I think yes. I think it's recursion, isn't it? Similarly, when our helicopter reaches here, okay, one guy will go here, one guy will go here, one guy will go here, and one guy will go here. This guy, after finding water, will tell that I have found water. This guy will tell I have found water. This guy will tell I have found water, as well as this guy will tell I have found water. So the guy standing here will know that in all the four directions I have water. That means I am an island, closed island. So it will say I am a closed island. So here we had a closed island, so we had one closed island. Here also we found a closed island. That means one more closed island. So total we have two closed islands. Okay. So this is going to be our approach, a recursive approach. We are going to traverse the area. If we found land, we are going to call our recursive method at that position. Okay, it will explore all the land areas and it will determine if it's a closed island. Okay, let's see the code, everything will be clear. Okay, so this is the solution. Okay, we get the length of our number of rows and columns. Okay, and we have a variable closed islands which is going to count the number of closed islands. Okay, so this is our helicopter which is going to roam over the area from index 1 to row -2. Okay, we are skipping the 0th and r -1, 0th and c -1 rows and columns. Okay, we are skipping them because why, we know that already. Okay, now if we see from above that it's a piece of land, we are going to deploy our people. Okay, it's either going to return us a true or a false. If it returns a true, it means that it's a closed island. Okay, so we'll increment it and at the end we will return. Okay, now let's see the method is closed. Okay, if we see that it's 1, that means it's water, we return a true. Okay, why? We saw that if we are at 0, we come to the one of the directions and we see that it's 1, that means it's water. It will tell its previous guy back that I have found water. That means in this direction it's a boundary. Okay, it's closed, so it will return a true from that particular direction. Okay, otherwise if we make past this condition, okay, it's definitely supposed to be a 0. If it's not a 1, it's going to be a 0, of course, right? So we will see if the 0 is on the perimeter or not. That means at the 0th and the r -1 rows and the 0th and c -1 column. Okay, if the 0 lies in one of these, okay, then it's never going to be a part of a closed island. For that I have created a method is on perimeter if it's on a 0, or if it's a 0th row, if it's the 0th column, or if it's the last rows and columns. Okay, if it's that the case, if it gives a true, that means we are standing on the extreme rows and columns, we will return a false. Okay, otherwise what we will do, we will sink that island. Why? Let's say we are here. Okay, we are here, we come to here. Okay, we come to here, but before coming that at that place we will make it 1. Okay, because from here also we are going to go to all four directions, right? But going back to this position from where we came from doesn't make any sense, right? So we will make this as a 1. Okay, that means this place has already been evaluated. You just go to the rest of the directions where we haven't gone before. Okay, so for that purpose only we have I have made it a 1. You can make it -1 also, anything you like. Okay, then from here, this is the part where we go to all four directions. Okay, we will go up, we will go left, we will go right, and we will go down. Okay, so this is pretty clear, right? Left is the previous column, that is j -1. Right is the next column, that is j +1. Up is the previous row, I -1, and down is the next row. Okay, I +1. Okay, if all of them returns a true, if all of them evaluates to a true, that means in all four directions we have a closed. Okay, it's closed in all four directions, so it will ultimately return a true. If any one of them is a false, means at that direction it's not closed, so it will return a false. Okay, so that's how this method is closed works. It's a DFS, right? So at the end we finally count the number of closed islands and we return it. Okay, so this is the simple solution. Okay, the time complexity of the solution is a big O of m into n, because at worst case our DFS is going to traverse the whole matrix, right? If all of them is a 0, right? Similarly the space complexity is also going to be a big O of m into n. Okay, the recursive stack space. Okay, so I hope it's clear. This is a very standard problem and standard solution. Okay, if you have solved the problem called number of islands, it is also very similar. Okay, so I hope you like this solution. If you did, do hit the like button, share this video and subscribe to my channel, and I will see you in the next video. Bye bye.